Hi, hello everyone. Welcome to today's session. Welcome to Unacademy and welcome to Srinivasarao Sir classes. My dear friends, today we are going to discuss the very important concept that is error detection codes. Before entering into the lecture, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. My dear friends, Unacademy has created wonderful online platform so that dedicated faculty members can be on a single rule. So my dear friends, so we all creditful to Unacademy. We have brought this idea. So get Plus subscription, access unlimited live lectures. About myself is Srinivasarao IS, having a more than 15 years of experience in the GATE with the various subjects. My dear friends, I also had industry experience as a database admin and a system analyst. Also had a good certifications in the relevant areas. Throughout the journey of GATE, I taught in many premium academies with a high success rate. Many of my students completed their post-graduation from India's premium institutions like IITs and NIITs, Central Universities and Triple ITs. You also can achieve the same just by clearing prestigious competitive examination called GATE. So GATE is going to give you a good settlement in your life. You are eligible for PSUs also. So all you need to do is to crack the GATE examination. You need to take a proper training from the proper educators, because especially in a competitive examination, you need to see that what to study and what not to study. If you study all the textbooks, for example, as far as the computer networks concern, like a Forizon and Peterson, Cruz and Ross, and William Stallings and Tannenbaum, then there is no use. And you need to see that what to study, what not to study. That's how we are going to segregate the syllabus. So according to that, if you prepare, you can able to get things well. So my dear friends, so to get into Unacademy, take the admission using my referral code, because admission prices are likely to increase from tomorrow onwards. So today itself you join, all the current fourth year students can opt for 12 month subscription. You're going to get for this price, because you're also going to get a good amount of maximizer discount. And you also see that, so tomorrow onwards this is going to be hiked by at least 30%. So today itself you join, 3 hours are left. By 12 o'clock this offer is going to be closed. Utilize this opportunity. Afterwards, if you want to join or if you want to subscribe to Unacademy, you won't get for this price. So already the things are spread over the country. So therefore, immediately you get joined today itself, because after 12 o'clock you cannot able to do anything. You need to pay extra to get the admission into Unacademy. So hurry up and take the admission. All the first years and second years and third and fourth years can also opt this Unacademy GATE subscription. And on 24 months also you are going to get a maximized discount price. My dear friends, let us start our today's session, and let's crack GATE CSC is our YouTube channel. Refer my referral code, use my referral code so that you're going to get a maximized discount, and you will be pinned to my batch. So whenever my classes are going on a plus, then you're going to see that you will be tagged with me. And hit the bell icon for latest notification and updates. And once you become a prime member, then you're going to see that you can able to see live classes, live quizzes, mock test, and unlimited lectures. That is the advantage with an academy. So let us say our session, error detection codes, why they are and what for they are. Error is nothing but during data transmission, because of noisy attenuation and signal losses and cable medium cut, So any kind of reason, the data may be lost. For example, you see you're watching a Tata Sky, suddenly clouds are formed, then you're going to lose your data. That means you're going to get some kind of errors during the data transmission because of the medium cut or medium inavailability, or you can say that noisy, or you can say that attenuation, and many varieties of things. That's why error is nothing but corrupted bit. Whenever you are transmitting some data during transmission, some bits may not arrive properly. Therefore, I can able to say that the frame consists of some errors. So what are the types of errors we are having? Single bit error and burst error. So single bit error is nothing but only one bit error you are going to find exactly at opposite side. Like parallel transmission, whenever you are talking, you are going to see a concept of one bit error. My dear friends, whenever I am saying that sender is going to transmit some data like 1010, and this is transmitting over the medium may generate some kind of a raw bit errors. And the data link layer is responsible to do, because physical layer cannot able to do any kind of error detection. And how to remove the transmission errors, physical layer do not know, because it is a what? Hardware based only. That's why upper layer is responsible for the error detection case. So if at all he received the data in this form like 1011, then the receiver side data link layer, this is done by DLL at the sender side, this is done by DLL at the receiver side. Whenever physical layer push the data to the upper layer and data link layer pushed the data to your physical layer, and this is being transmitted through your media, and medium you go see that there may be some chances of bit errors or corruptions. So whenever you see that the data is corrupted, and the data link layer is going to be observed that is there any error or not before accepting the frame. If there is a no error, then immediately data link layer unwraps that header and trailer, it puts the data to your network layer. Otherwise, it is going to give you a negative acknowledgement that your data has got corrected in the frame, then the sender has to retransmit the corrupted frame. So that's why your process gets stopped whenever you see that, whenever you receive a corrupted data frame. So data link layer at the receiver side is responsible to detect these kind of errors. According to this example, we understand that. So sender is sending a 1010 and the receiver is transmitting the data, unfortunately 1011. We understand that this is error, remaining all are correct. I can say that it is a 1-bit error. So my dear friends, there may be a chance of 1-bit error, especially we are going to see in a parallel transmission. I already shared in the class transmission modes, please recap. And what is the meaning of a burst error? Burst error is nothing but multi-bit errors. When I am talking a burst error, it is a multi-bit error only. So that means the data frame may consist of multiple bit of errors. So here sender is sending the data such that 101010, and this is being transmitted over the medium, and receiver side physical layer received the data as 10 and 00 and 11, and this is arrived at the receiver side like this. And before you transmit your data to upper layer by unwrapping of your header and trailer, data link layer first observe that are there any raw transmission errors or not. So I'm going to cross check, because we know I can able to say that sender has transmitted 101010 and the receiver has received the data is 1000 and 11. So we are trying to cross verify that how many errors are there. So this is error, this is a correct, this is a correct, this is a error, this is a correct, and this is a correct. So we understand that according to that is a 2-bit error, but it's wrong. Examiner will ask you that what is the burst length? So what is the length of the error? So the burst length is nothing but starting point of your error to ending point of your error. Reminding, we are not going to consider even they may be arrived correctly or may not arrived correctly. Therefore, I can able to guess that this is Correct. This is correct. This is your starting bit of error and this is your ending bit of error. According to that, our burst length is nothing but 4. This is how you can able to say that burst length. I'm going to discard the next upcoming characters because even though they arrived correctly, I don't mind. I will see that start of the position to end of the position. My dear friends, observe carefully. Whenever you see the burst errors, then you need to use a proper mechanism to detect the burst errors. Whenever you are having a single bit error, you need to use a proper mechanism to detect the single bit errors. That's why we are presenting here single bit detection mechanism and a burst errors detection mechanism. My dear friends, who is responsible to do this kind of error detection and error correction? Data link layer, the first part is a LLC, logical link control is responsible to do this error detection and error correction. So therefore, trailer, data link layer, trial is responsible to place your error detection code and correction code. My dear friends, that's why the only one layer who is taking care of a trailer, who is injecting the trailer to your data is a data link layer only. So what is error control? Error control is nothing but we want to maximize to decrease the errors. So therefore, data may be corrupted during data transmission. You and I cannot able to give any guarantee that without data loss can you able to transmit. No. 99.99% if you are using a wired medium, your errors are going to be very less. But when you are using a wireless, probability error is a more. But I cannot give 100% data transmission without any error unless and until examiner will say that error-free channels. If it is erroneous channels, there is 100% chances of errors. So for reliable communication, errors must be detected and corrected. So who is responsible? I am talking one of the responsibility of your LLC is error control. So using the LLC, one of the responsibility error control, we are trying to detect the errors and trying to correct the errors. If not, we will see automatically sending a negative acknowledgement. Before sending a negative acknowledgement to others, I will try to correct myself errors. If not, I will send a negative acknowledgement. So before sending a negative acknowledgement to others, you try to see that your errors can be corrected or not. But before that, you need to see that whether there are errors or not. They are going to be identified using error detection codes. So your error detection codes are placed in a trailer of the frame. When you look at the structure of your frame according to the last one, your frame has got a header, your frame has got a trailer, and we are having the concept of start of delimiter, and we are having the concept of end of the delimiter, which is nothing but we assume that there is a flag. So this trailer is for error detection codes according to today's agenda. So what are the error detection codes are there? And to detect d-bit errors, there is a requirement of minimum Hamming distance is d plus 1. That we will see in the next class. But today class is what are the different kinds of techniques are there to detect errors. I will show you one important example here. In order to detect error, you need to have what is that? One more set of copy with you. So therefore, the other party can able to detect the error. I have a question to you. Who is the responsible? Who is the responsible to detect the error? Who is responsible for the detection of error? For detection of error, who is responsible? That is, we all know data link layer. Which side? Receiver side. So receiver side data link layer is responsible to detect errors. How he can able to detect? The second important point is that there is a requirement of one more set of code word, one more set of your data. So one more set of data is required. One more set of data is required to detect errors. That's why I'm going to present an example to you. For example, if I'm saying that there is a sender, he is sending a data 1010 and which is coming to the medium as 1011. As 1011, are there any errors? How the receiver side data link layer can able to understand that are there any errors or not? Because you do not have what the sender has been transmitted, my dear friends. Sender has pushed some data and during data transmission the bits are flipped and flopped. So 1 may become 0 and 0 may become a 1. Therefore he is sending what I mean to say 1010. Unfortunately they have been arrived 1011. The receiver do not have this part because the sender has got that part and receiver has got only what the receiver has got. That's why how he can able to identify the error. This is the $1,000,000 question. That's why whenever receiver do not have a second copy of data and how he can able to detect the errors, this is impossible. That's why there is a requirement of what? Error detection codes. So these error detection codes are used at the receiver side. Exactly, my dear friend. So these error detection codes are used at the receiver side to enable the receiver to detect the errors. So what are the different mechanisms are there to detect the errors is the number one is redundancy, parity check, cyclic redundancy checker and checksum. Four different varieties are there. Hamming distance is also there to detect errors that we will see in the next class. Today we try to cover these things. Now, whenever you talk about the error detection codes, they are called as a forward error detection. This is very important. Backward error detection means frame lost, frame damaged, frame corrupted, acknowledgement is delayed, acknowledgement is corrupted. They are called backward error techniques. Forward error technique means in order to detect your bit errors. Backward error detection means in order to detect your frame errors. What is a frame errors? Frame may lost. Entire frame may lost. Frame may damaged. And acknowledgement may lost. Acknowledgement may be delayed. That's why these error detections are being two separated. One is bit level, the other one frame level. Frame level we are going to see after few days. That is backward error detection using frame lost, frame damaged, acknowledgement lost, acknowledgement delayed cases. So here, as we are learning a forward error detection codes, unless and until these are being detected, you cannot able to send the data to your uppermost layer. So what is the concept of EDC, error detection code? It is the concept of embedding redundancy, injecting redundancy into your frame by adding extra bits for detection of errors at the destination side. I have one more question. I said that receiver is responsible to detect the errors. But what is the responsibility of the sender? Sender is the responsible for the construction of error detection codes. So sender is responsible for construction of error detection codes. For construction of error detection codes, after construction, these error detection codes are being placed into a field called trailer. If anybody asks you, what is the maximum size of the trailer? How much is your maximum error detection codes can be supported? According to Ethernet, I am talking because Ethernet is our really real-time medium. Ethernet, according to Ethernet, the trailer maximum size is only 32 bits. That's what, my dear friends, you can able to have a maximum of 4 bytes or 32 bits only. You cannot keep more than that error detection code. So sender is responsible to construct the error detection codes and they have to be placed in the trailer. Now let us see the first variety, that is called redundancy. Advantage of redundancy is a superb. So what is the redundancy? Same set of data is used as error detection code. What is the advantage? Very easy technique. And what is the drawback? The drawback is overhead. This is a very important. The drawback is overhead. Why overhead? I will show you. If data part is increased, automatically redundancy is increased, therefore overhead is increased, and your efficiency is decreased and your throughput is decreased. Observe, my dear friends. So how the redundancy is being added to your original data, I will show you. For example, sender, whenever I am saying that, please think that we are learning data link layer, especially we are learning logical link control. 801.2, 80 IEEE 802.2. Now you observe this. Whenever I say that a sender is transmitting some data like 1010, this is your data which is coming from your upper layer. Please understand. First internet layer send data to data link layer, and the data is this is only. So 1011 is a coming, and I want to provide some kind of redundancy in the form of error detection code. Therefore, I will construct the frame. The frame consists of a header, and a frame consists of 1011 data, and frame also consists of your EDC trailer. You are going to place your EDC in the trailer. Your trailer is going to consist of 1011. It's a very easy technique. Whatever data you are taking the same data I am using as a redundancy. So we will transmit this to the receiver. As soon as the receiver receives, the data link layer receives this, then it is arrived like this. How it is arrived? Header is okay, 1011 okay, and he received 1011 in the trailer. Now what is going to happen? He will cross verify bit by bit. So I can understand that 1011 is your data. One set is available and another set is available also like this 1011. This is your EDC. Therefore, I will do once again like this. So I can confirm that all are arrived correctly. Just I am doing a mapping from your original data to your EDC. All are success. Therefore, according to that, the data link layer at the receiver side understand that there is no error. Now observe, my dear friends, if I am taking like this, receiver side DLL, receives a frame. Directly I am saying without sender one, I am just transforming at the receiver side only. This is your header. About header we will see tomorrow. What are the header parts and all later on classes. This is your data. This is your trailer. So our trailer is 1010. Now we will do operation between your data and your trailer. So we understand that the bits are mismatched. This is a 1011, this is a 1010. We understand that this is your error. Therefore, I confirm that it is a 1-bit error. So you may get a doubt. There may be a chance of trailer may be corrupted. There may be a chance of data may be corrupted. Yes, I do agree. So trailer may be corrupted or there may be a chance of data to be corrected. Hence, there may be a chance of identifying an error. That's why to identify an error, there is a requirement of another set of ambiguity code, redundancy code, so that the other party can able to detect the errors. So here, I am injecting 4 extra. Your overhead is 4 bits. So let us see like this. For example, if data is 1000 bits, now tell me if I am using redundancy as one of your error detection code mechanism. And what is your overhead? Those who are online, please tell me, what is your overhead here? So your data is 1000 bits, and I am using a redundancy is your error detection code mechanism. My overhead is also how much, my dear friends? 1000 bits only. But according to Ethernet, this is invalid because Ethernet can able to take the maximum of 32 bits only. That's why redundancy is a mechanism is always preferable because each frame is having a different trailer formations. So your trailer cannot able to give you what I mean to say more than 32 bits according to Ethernet standards. That's why we want to see that according to this example, what do we understand? According to this example, if n bit data is there, if n bit data is there, then you say that if I am using redundancy technique, then I am going to have n bit error detection code. So therefore, you observe according to this example, your overhead is exactly n for n. And what is your link efficiency? Useful divided by total. Your useful is n data bits, and your total is n data bits plus n overhead bits. Therefore, exactly it is a n by 2. And I can confirm according to this, you are going to have a concept of 50% of link efficiency. So your link efficiency is being drastically down as it is a 1 by 2. That's why redundancy we are not going to follow. What is our assumption? The assumption is that irrespective of the size of your data, it may be 1000 bits or 2000 bits or n bits. We want to use only 1 bit error detection code. See the beauty of the next mechanism. What is that? Irrespective of length of your data, I don't mind. I want to use only 1 bit error code. That is the meaning of a parity. So the beauty of the parity is whatever data you are having, I don't mind. I'm going to give you only 1 bit error detection code. So there are some advantages and disadvantages of parity. I will show you. Just hold on till the end of the lecture. Don't miss from today's class. Not only today, from yesterday class. They are all important according to competitive examination. Now 1 bit parity EDC. That's the meaning of this. So what is the parity? It is a 1 bit error detection code. Can detect simple errors. Simple means single bit errors. Simple errors. Can also detect burst errors. Can also detect burst errors if length of error is odd. That means it cannot, this is the limitation, it cannot detect errors, it cannot detect errors for even length. This is the limitation of your parity. And there are two types of parities we are having. We are having two types of parities. One is called even parity and the other one is called odd parity. So what is even parity? Even parity is nothing but the total number of ones, including parity bit, including parity must be even. What is the odd parity? The total number of ones including parity must be odd. Including parity must be odd. So there are two varieties of parity mechanisms. One is BRC, the other one LRC. Parity techniques. One is vertically redundancy checker, a longitudinal redundancy checker. Two varieties. So first of all, we will learn about vertically redundancy checker. So when I am talking vertically redundancy check, it is a one-dimensional. It is a one-dimensional. Parity is calculated either column for row. Parity is calculated either for column or row. Now let us do it, and how the errors also detected we will send. First let me speak at the sender side what is going to happen, because sender is responsible for the construction of error detection code. Now listen, data is 101011. I am using even parity vertically redundancy checker. So how the frame is being constructed? Take the frame. Your frame consists of header. You forgot about your end of the delimiter, start of the delimiter, already we discussed. Today our task is only trailer only. So your data is 101011. Now I need to add even parity value. So even parity value is nothing but number of ones must be even including your parity. So 1, 2, 3, 4. There are 4 ones are there. So your parity value is 0. So you understand here, my data is n bit length. My data is n bit length. I don't mind. I am using only +1. That's why there is a requirement of what? To detect a d bit errors, there is a requirement of minimum Hamming distance is a d +1. This is important equation. To detect a d bit errors, there is a requirement of d +1. +1 is nothing but your parity value only. So irrespective of your data length, I am just adding only 1 bit as your error detection code. This is only your EDC. Now the frame is being pushed. How the frame is being pushed? It is pushing as like this, header, and your data 101011, and EDC also is attaching to that. Now whenever it is transmitted through the medium and the receiver side DLL is received from the receiver side data physical layer, the data is arrived like this: 10 and 01 and 10 and 0. Now is there any error? Please tell me. So he will receive as a header, and this is going to be your trailer, and we understand that this is your data according to yesterday frame construction. So we understand that. So you need not worry that there is a no, you are not having a center side data, because he has provided us error detection code. Now it is even parity, I know, but I can understand that even parity is wrong, because number of ones are not even, number of ones are becomes odd, and I can consider that there is an error in this, error in the frame. This is how you can able to identify error at the receiver just by recomputing even parity or odd parity at the other side. Well, my dear friends, so according to this, even parity is a failed because sender has sent the EDC only just by computing even parity. Now here there is a big problem. I want to ask a question. I detected error, but where is the error? Error is there. I don't have sender side data. And where is the error? This is a big problem. So vertically redundancy checker, whenever you say vertically redundancy checker, whenever you say it is a one-dimensional, parity value is calculated either for row or a column, but Burst errors are nothing but, my dear friends, multi-bit errors. More than one bit error. Which burst length is going to be measured from starting of the length of the error to ending of the length of the error. That is a burst error. So according to this example, what is the drawback of VRC? According to VRC example, VRC advantage is easy mechanism. But what is the drawback? Cannot detect what? Error positions. It can detect there is an error, but it cannot detect error positions. And one more example I will keep. Tell me, is there any error or not? So sender side data link layer is sending data 101010, and the sender is constructing a frame header 101010. Yeah, one see now. And I am saying that there is a trailer. So we are assuming that I am going to use VRC with even parity. You can take odd parity also, no doubt. Even parity I am taking. So here your even parity is a 1. Now this your data plus your EDC together is being transmitted to the receiver. Now receiver received. Assume that if receiver received like this, a receiver received 100101, reverse we will write 010101 and 1. Now tell me, is there any error? Just you type your comment. Is there any error? A receiver received data like this. Is there any error? So receiver is going to recompute even parity. So here you understand that after finding even parity, after recomputation of even parity, we understand that even parity is a success. So when even parity is a success, I will say that is there any error? I will say no, no error. Why no error? Because even parity is success. But realistically, there are errors. How many errors are there? How many errors are there? Starting of the error point to ending of the error point. Almost all 6 errors are there. In middle, I don't mind whether they may be arrived correctly, they may not arrived correctly, I don't mind. Burst errors are nothing but multi-bit errors which are going to starting of the point to ending of the point is your burst line. So according to this even parity scheme and with the VRC scheme, I'm saying that is there any error in the sense I cannot say that there is an error because even parity is a fortunately success. Why even parity got success? I already gave you limitation with the parity. What is that? Parity can detect only odd length of errors, not the even length of errors. If you understand what is the error length here, please tell me anybody. What is error length? What is your error length? Sender has sent 101010, but receiver has received 010101. So what is your error length? Anybody? What is your error length? My dear friends, 6 bits are flip and flop. So your 6 is even. 6 is an even number. Therefore, it cannot able to detect even length errors. It can detect only odd length of errors. Even it detect all length of errors, but it cannot able to give you what error where the error position is there, that he cannot able to identify. Therefore, my dear friends, as far as by human being we can understand that this is what the sender has been transmitted, this is what the receiver has been received. So therefore they are ulta palta arrived, jumbled ho gaya. But we want to see that whether there is error or not. Receiver side do not have the sender format. Therefore, he has to have only one help just by recomputing of your even parity. If even parity is a failed, then we will understand that error. But even parity is a success, we can understand that there is no error. According to here, even parity is a success, therefore no error. But realistically, there are all our errors only here. So my dear friend, so probability that VRC can't detect error in n length data. So it can detect error even in n length of data, but thing is that the error length is supposed to be odd, not the even. Error length is supposed to be odd, not even. So for odd parity, what have to we add? First, let us see odd parity calculation. One see, I am saying according to that. So VRC, I am taking my data is 101010, and we are saying odd parity I want, and I am following VRC here. Now let us see how the sender is going to start construct the frame. He is adding a header. Your data is 101010, and odd parity is nothing but number of ones are supposed to be odd. So your number of ones are already odd, therefore you need to use 0. So here we are going to use a odd parity as 0 because your number of 1 bit positions are odd. So when you send this data to the receiver, 101010, and let us say otherwise 101011, and 0 got arrived. Now when we want to cross check odd parity is satisfied or not. So according to that, odd parity is satisfied or not. So we need to check the number of ones are supposed to be odd. Here if you understand the total arrived one, this is a total arrived one. So you see that number of ones are even or odd. So 1, 2, 3, 4, the number of ones are odd. Therefore odd parity is dissatisfied. So whenever parity is dissatisfied, now I can say that there is an error. So this is how you can able to see that VRC can detect simple errors, also burst errors in the event of the length of the error is odd. Now let us see the second variety is LRC. LRC is longitudinal redundancy check. So what is the advantage here? Superb advantages. First one, it is a two-dimensional. Second one, parity is computed for rows as well as columns. So what is the advantages and what is the disadvantage? Advantage, if you consider, can locate error position. But what is the disadvantage? Overhead increased. Because we are finding row parity as well as a column parity. Overhead is increased, therefore your efficiency is going to be decreased. And now let us see an example for this. The example like this. There is a sender Sender in the sense data link layer only, which has got data from your upper layer, that is internet layer, and the data is arrived like this: 101011 0011 000100. Now he is asking you to find even parity using LRC. So the solution begins. Step number 1, write in the form of two-dimensional matrix. Write your data in the form of two-dimensional matrix. You see that I am taking 4 into 4 matrix. You can take any matrix. If at all your data is not satisfied, you please inject extra 0 bits. In order, if you see that your matrix is not satisfied properly, then you can able to inject extra 0 bits. I am taking, let 4 into 4 matrix I am taking. So your 4 into 4 matrix are, so 1, 2, 3, 4. And next one is 1100. Next one is 1100. Next one is 0100. Now you start find row parity and also column parity. So both sides the same computation is going to be done. As you said that even parity scheme we are using, so I am using even parity scheme. So number of ones must be even. Yes, it's even only. So don't make it a 1. Don't invert it. So number of ones are supposed to be even. Yes, it is even. And number of ones are supposed to be even. Yes, it is even. And number of ones are supposed to be even. It's not even. Add 1. Now for the column also we are doing the same. So number of ones are supposed to be even. It is in the odd. So I need to raise a 1 here. And here also 1. Here also 1. Here already number of see that they are same. So I am going to raise 0. And here number of ones are supposed to be 1. I am taking it. Now this is a completely parity. And this is a completely parity. So how many parity bits we added? So what is overhead? Your overhead here is almost all, so 9 bits. 9 bits are overhead out of your 16 data bits. And what is your link efficiency? Your link efficiency is useful divided by total. 16 bits are your useful. Total I am sending your data bits plus your overhead bits. Yes, my dear friend. So these are all not there in real time. But actually, right now we are using cyclic redundancy checker. Please observe. You want to learn the cyclic redundancy checker and you want to learn checksum. We are using two error detection code mechanisms. One is called CRC, the other one is called checksum. And you want to use Hamming distance. Hamming distance is also we are using in some of the real-time applications. So you want to find a Hamming distance, you need to know what is the code word and how the code word is supposed to be constructed. Hamming distance is a completely using a parity scheme. That's why we are learning a parity scheme here. So these are all involved in real-time syllabus. CRC is a real-time application of Ethernet, and FCS is real-time application of your ring, and your checksum is a real-time application of your IP internet protocol. Checksum is a real-time application of your TCP. Checksum is your real-time application of your UDP. and checksum is real-time application of your ICMP. So observe that without these you cannot go forward. That's why these are given in the syllabus. So why are we using a 25 bits? Because the 16 bits are your data and 9 bits are extra. 9 bits are being used as a form of what? Parity. 19 plus 6. So 16 bits. 16 bits are your original data and 9 bits I am using as your parity bits. Now let us see, this data is we want to present it to the receiver side. Is it clear, my dear friends? Why 25 bits? This is how the 25 bits have been transmitted. Exactly, Aman Verma. So 16 plus 9. Clear, Amit Kumar? Now let me say one important thing. If the same data is being transferred to the receiver, same data I am taking at the receiver side. The same matrix with including parity has come to the receiver. If receiver receives payload, it's not data, payload or a frame as follows. So he has got data like this. How the data is being transmitting from the sender. Row by row it will be transmitted, my dear friends. This is your first row. This is your second row. This is your third row. This is your fourth row. This is your fifth row. Row by row data will go. So first he is received 10100. 10100. And next he received 11000. So next one is 11000. And the next one is 11000. And the next one is 01001. And the next one is 11101. Yes, Amit Kumar, you are right. CRC means cyclic redundancy checker. Yes. So now you see, whenever he got received the data, he is trying to reorder, but you understand, this is your parity, this is your parity, this is your parity, and one more. So 1, 2, 3, 4. This is your parity, and these are all your parities only. So this is how the data is arrived at the receiver side. So now receiver is forming into 2 into 2. So I am telling about receiver side. Yes, my dear friend, you are right. N into n, we use a 2 into n plus 1 parity. 2 into n plus 1 is for error corrections. Error detections d plus 1. 2d plus 1 we are using for what? Error correction. Now receiver side is arranging two-dimensional matrix. That is a 4 into 4 matrix I am taking. Now you see 1 0 1 0 0 1 1 0 0. Please observe carefully. 1 0 0 0 0 and 0 1 0 1 1 1 1 0 1. This is how the receiver received. The receiver received like this, and he arranged the data according to how he received and how the sender has been transmitted. Now what the receiver has to do? Receiver is going to do recomputation of even parity. Recomputation of even parity. So let us see, even parity is a success for every row as well as every column or not. First one, first row 1, 1 0 1 0. So even parity is a success because the number of ones are even in that row. 1 1 0 0 0, even parity is a success. 1 and 4 0, even parity is not success. 0 1 0 0 1, even parity is a success. 1 1 1 0 1, even parity is a success. Clear? Now you see, column side you tell me even parity success or not. First column 1 2 3 4, even parity is a success. 1 2 3, even parity gone. 1 2, even parity success. And even parity success. Even parity success. That's it. You got to understand that there is a 1 bit error. There is a 1 bit is misplaced. 1 bit is a corrupted. What is that error location? You know the error location now. What is the error location? The error location is the intersection area of your even parity, row even parity and column even parity. Exactly. This is a column a vertical checker. This is a even parity wrong. Therefore, I can understand that the intersection is your error. So last row even parity is a success. Yes, 1, 2, 3, 4. 1, 2, 3, 4. 4 ones now. 4 ones means even parity success. Even parity is nothing but number of ones are supposed to be even. Now tell me, my dear friends, where is the error? Error location I can able to find. Where is error? The intersection area of your even parity and row parity is your error. So according to that, I can understand this is your error. This is your error. Now whenever I know error, where is the error? Error is exactly which position? Now let me tell you which data position error is. So this is your data. This is your data, and data, and 8, 9, 10th. So you will understand that 10th bit is error. So you also see 10th bit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually sender sends 1100, but receiver receives 1000. That's why we understand that this is an error. This is an error. So this is how I can able to detect errors using a longitudinal redundancy checker. But there is a limitation, my dear friends. What is the limitation? Same limitation. It also unable to detect even length errors, but it can detect any length of a burst error by using odd length position. As one is a odd, that's why it can able to detect 1 bit error easily. So what is the main limitation of your parity? Yes, Aman Verma. You want to do, you can do it. So you can change it and see that even parity or odd parity is success or not. 100% you are going to see that if at all there are other errors are also there, they are also going to be errors only. So you can able to find the same. For example, you want to change me this, I can able to change. So you modified instead of 1, you modified here as a 0. Then automatically you can understand that even parity is a failed row wise as well as the same column wise is also even parity is going to be failed. Then the intersection I can able to understand that that is an error. Clear na? Aman Verma. You can check yourself, but only one limitation. What is the limitation? Same. It can only for odd length. It can only for odd length, not for even length. Odd length burst errors. Not. even length. Same story, because that is the weakness of your parity. Why the parity has got that weakness, that I will release in the tomorrow's session. Why parity has got that weakness, that is that it can able to detect only odd length. Why not it is detecting even length, that we will learn in the tomorrow's lesson. So my dear friends, we have learned today what is a redundancy and what are the problems of redundancy, and we have rectified in parity. In parity we learned VRC. The problem with VRC is that location cannot be identified. Location cannot be identified. So that problem we have identified in LRC. That problem is rectified. So you can find a location also. Location can be identified. But what is the problem altogether with parity? Parity is one of the best technique. Parity is one of the best technique because for your n bit data, I am taking only one bit only parity. According to your VRC and according to your LRC, you are supposed to use the concept of what? Row parities and column parities. But what is the limitation? This is the limitation which are there in your VRC and which are there in your LRC, that you can able to solve in tomorrow's lecture. Why we are able to not able to deals with even parity by learning CRC and checksum and others. Thank you very much, friends. Share this knowledge to everyone. You now you become a good knowledgeable person, because this is my, I think so, 10th class. All 10 classes, once you revise, then you also will become an educator. You can start whatever you want, because already these things are there in your hand. You will be the next upcoming educators, as we are updating soon by soon. So you want furthermore knowledge, please see, join into Unacademy, because by 12 o'clock the offer is going to be completed. The fees are going to be increased after 12, today after 12. So immediately join, but my request is please join with my referral code, and you are also going to get a good amount of maximized discount in Unacademy. Whenever I start a plus course, then you will be a members to me. Thank you very much. Thank you very much, and good night, my dear friends. Yes, that is the meaning of CRC and checksum, my dear friends. Bohra. So that logic we are going to use in tomorrow's session.